Now coming to the next distribution, that is we will see binomial distribution, and then we will move to Poisson distribution. So what is a binomial distribution? So before looking at the formula, let us look at an example here. So a quality control inspector checks light bulbs coming off a production line. Each bulb has 95% chance of being non-defective. Okay. If inspector randomly selects 20 bulbs, what is the probability that exactly 18 are non-defective? Okay, so you are randomly selecting 20 bulbs. That means, so what is the probability that only one bulb out of these 20 bulb will be non-defective? Okay. Similarly, what is the probability that 2 bulbs will be non-defective? You can go up to 20 bulbs. What is the probability? Okay. So that means if you plot 1, 2, 3, etc., 20, then if you plot the probabilities here, okay, if you plot the probabilities, you will get a curve, and that is called a binomial distribution. So now let us look at the formula for that. Then we can calculate the probability for it. Okay, so just by intuition you can see that each bulb has 95% chance of being non-defective. That means when you take 20, if it is 50% chance of being defective, that means when you take 20, out of which 10 may be defective and 10 may be non-defective usually. But since it is 95%, we can see that when you take 20, around maybe 18, 17, etc. will be non-defective. So to calculate that, you need a formula, that is P of x is equal to 1. Okay, P of x is equal to 2, etc. So P of x is equal to 1 is equal to, so it is NCK into, so what is the probability that it will be non-defective? That is P raised to K into 1 minus P whole raised to N minus K. So here you can see that either the bulb is defective or non-defective. Okay, the probability that the bulb is non-defective is 1 minus P. So P here is 0.95 and K here is 1 and N is 20. Okay, so if you calculate this, you can calculate it for P is x is equal to 2, x is equal to 3 and up to x is equal to 20. So you will get corresponding probabilities. Okay, so it will be like this. So you can see that the probability that only 1 will be non-defective is very low and 2 is very low. So it will have a curve like this. Okay, and in this case you cannot join this because these are separate numbers, not a continuous case. Okay, so this is called a discrete distribution. Okay, there is no number like 2.5, 2.54, etc. In the earlier case, for the case of a BESS, you can see it is 9 and 930. So all these numbers are continuous between 9 and 930. And here it is not continuous. It is 1, 2, 3, etc. There is no 2.5, 2.34, etc. So this is all about a binomial distribution. This is a discrete distribution. Okay, let us look at the formula once more. So this is the formula. So Px is equal to k, probability that our variable takes on the value k. Okay. So always remember this, for any distribution, what we are doing is we are tracking the probability of the numbers like x. It can be continuous as well as discrete, like 1, 2, 3, etc., or 1, 1.1, 1.2, like that it goes on. Okay. Then in y-axis you have the probability, that which you have this formula. You can use this formula to calculate the probability.